Today we're going to use all of our techniques of factoring to simplify rational expressions. Basically what a rational expression is it's just an expression that's described by a fraction, so you can write it as a fraction. Now we know that any fraction having a denominator of 0 is undefined because we can't divide by 0. Any value that makes that denominator 0 is called an excluded value. So you'll see in this rational expression right here, if b equals -7, then the denominator equals 0. Therefore, b equals -7 is an excluded value. Now here, in this next fraction, I'm not sure what the excluded value is just by looking at the expression. But I know that I have a trinomial in the bottom that probably factors. So if I ask myself, well, what will take and make ax squared minus a minus 12 equal to 0, and I can solve that polynomial, then I can state my excluded values. I know this factors once again what multiplies to -12 and adds to -1. That's going to be a -4 and a +3. And then I have a zero product principle saying a minus 4 could equal 0, or a plus 3 is equal to 0, so a is equal to 4, and a is equal to -3. And both of these are excluded values. So now we're asked to simplify this expression and state the excluded values. I kind of like to do it opposite because whenever the denominator is 0, whether or not it's simplified or not, those are excluded values for the function. So I'm going to take and set x squared minus 5x minus 36 equal to 0, factor that, get x, 9 and 4 are going to make 5. That's a -9 and a +4. So x minus 9 is equal to 0 by the zero product principle, or x minus 4 equals 0. Therefore, x equals 9 and x equals -4. These are my excluded values. Now, let's talk about simplifying an expression. 2/4 is a rational expression. That's equivalent to 2 over 2 times 2. Notice these are the prime factors of 4. Any factor over itself can reduce to 1, so this reduces to 1/2. That's an example of simplifying a rational expression. We're going to do the same for this more complicated one. I'm going to look at the numerator and see if I can factor that in any way. I notice there's a common factor of 4, which leaves me with x plus 4. And in the denominator, we notice this factors. Now I've already done that factoring over here to x minus 9 and x plus 4. We've already said that any factor divided by itself is equal to 1. So these reduce, and I'm left with 4 over x minus 9 is my simplified fraction with the excluded values of x equaling 9 or -4. Let's do the same for this next example. We are going to find our excluded values first by taking the denominator and setting it equal to 0. We know this factors into w plus 8 and w minus 2. That gets me a -16 when I multiply and a +6 when I add. So w plus 8 equals 0 and w minus 2 equals 0 due to the zero product principle. W will equal -8 or w equals 2. These are my excluded values. And then I want to simplify this. Once again, I'm going to look for any factoring in the numerator. 5's in common, left with w minus 2. The denominator factors into w plus 8 once again, and w minus 2. This is similar to the last example. Same factors of w minus 2 reduce, and I'm left with 5 over w plus 8. Let's go ahead and do this again. This is going to bring about a little twist in our problem. Let's start by looking at the denominator and saying, well, what makes that denominator equal 0? I don't want to guess, so I'm going to set it equal to 0. 8x minus 40 should equal 0. And I can solve that by adding 40 to both sides. So I get 40 equals 8x and divide by 8, and x equals 5, and that's an excluded value. Now let's go ahead and simplify, and this is where this problem is going to get a little bit interesting. Now personally, I am never a fan of having a negative squared term in my problem if there's only one squared term. Sometimes you'll have two squared terms, and in that case, one of them could be negative, and that's just the way it goes. But whenever I have a negative squared term, what I'll always do is I'll first begin by factoring a negative 1 out. So when I factor a negative 1 out of the numerator, I get x squared minus 25. And the denominator I know factors in, well, I haven't factored that yet. There's an 8 in common. And that's my GCF. And I'm left with x minus 5. Now if you'll notice, the numerator has a perfect square term in it. And it's a difference of two squares. So we know how to factor those. That goes to x and x, 5 and 5. And since I need a negative, I'm going to have a positive and a negative term. And that's all over negative 8 times x minus 5. Any common factor over itself reduces. So I'm left with negative quantity x plus 5 over 8. And that's my reduced fraction with an excluded value of x equals 5. So in this problem, we aren't asked for any excluded values, mostly because we have two different variables in the problem. We're just asked to simplify. The top is already done. I can't factor that at all. There are no common terms. So I'll just list that again. The denominator, I notice a 7 is going to go into both of those. I have an a in common and a b in common. So that's my GCF. I'm left with a 3 and an a for my first term, and my second term I have a 7 and a b squared. Now, only factors are able to be reduced, and any like factor that goes into each other can be reduced. Notice I see a b squared here and a b squared here, but the factor is 3a plus 7b squared. I can never reduce those two. They all have to be reductions over multiplication and division. In fact, let's write that. Reduce only over multiplication and division. Never addition and subtraction. So in this case, I see a 7 over a 7. That reduces. I also see an a cubed and an a squared. And notice those are separated by multiplication, so I can reduce those. They reduce to, remember, if I have a common base and a division of powers, I take and find my largest power, which is my a cubed, keep my answer there, which is the numerator, and subtract the powers. So that's a squared. And then you'll notice I've got a b squared and a b, which reduce to b in the numerator, leaving me with a 3a plus 7b in the denominator. And while, once again, I have a's in the numerator and denominator, and b's in the numerator and denominator, I can't reduce any of them because this whole denominator is linked by addition. So this is my final reduced term. So in our last example, we're going to primarily do what we've been doing all along, except the actual factoring is going to be a little more difficult. You'll notice in the denominator of this first term, there are no common factors. So I'm going to have to use a 5-step method. X squared minus 20x plus 36 is equal to 0. Two things that multiply to 36 but add to negative 20 of an x and an x, and an 18 and a 2. Both need to be negative. And then since we're doing our 5-step, we have to divide both terms by 3, which was our original multiple, leaving me with x minus 6. And since the 2 and the 3 don't reduce, I bring the denominator forward. So that's 3x minus 2, and both those equal to 0. Therefore, x minus 6 equals 0, and 3x minus 2 equals 0 by the zero product principle. X equals 6, and 3x would equal 2, so x equals 2/3. And these are my excluded values. Now we'll have to factor the numerator. Again, there's no common term, so I'm going to use a 5-step method there. I have x squared plus 17x minus 6 times 14 gets me 84 is equal to 0. We'll have to find out what multiplies to 84 and adds to positive 17. That's going to be 21 and 4. So I've got x plus 21, x minus 4, that doesn't need to be equal to 0. I divide each of those by 6 because we're doing that 5-step method. I get x, 3 goes into both of these, so I get 7 and 2 for the first term, and the second term I get 2 and 3. Since neither reduce to a whole number, I need to bring both denominators forward, giving me 2x plus 7 and 3x minus 2. And that's the factoring of the numerator. So now I'm going to take and show the factored numerator form, which is 2x plus 7 and 3x minus 2, over the factored denominator, which is over here on our left, of x minus 6 and 3x minus 2. Notice I have common factors of 3x minus 2, which will reduce, leaving me with a simplified rational expression of 2x plus 7 over x minus 6 with the following excluded values. Quite a bit of stuff. Again, we're reinforcing our factoring. We're going to be doing this for at least another week, or things like this. So let's make sure we get our factoring down. Write your lesson summary, solve the equations below, or simplify the expressions, and we'll talk about this more tomorrow.